What if Tesla's most important product isn't a car at all? Forget the Cybertruck, forget the semi, forget even the next generation Tesla vehicles. Elon Musk once made a surprisingly bold statement. The company's humanoid robot, Optimus, could eventually become more significant than Tesla's entire vehicle business. And that statement wasn't just about building a cool robot that can walk around. Musk was talking about something much bigger: labor, manufacturing, automation, and potentially the entire structure of the global economy. So why would Tesla put a humanoid robot ahead of new car models? And what did Elon Musk see in Optimus that made him call it one of Tesla's most important products in development? Let's break it down. The story goes back to Tesla's 2021 AI Day, when the company surprised the world by announcing that it was working on a humanoid robot. Tesla called the project the Tesla Bot, but internally, it became known as Optimus. At first, a lot of people treated the announcement almost like a futuristic side project. After all, Tesla was already building electric cars, developing autonomous driving technology, working on the Cybertruck, the Semi, and the Roadster. A humanoid robot seemed like an entirely different business, but Elon Musk clearly didn't see it that way. During Tesla's Q4 2021 earnings call, Musk explained that Tesla would not be introducing new vehicle models in 2022. The reason was fairly practical. Tesla was still dealing with supply chain and component constraints, and those limitations were affecting multiple projects. But there was an interesting part of Musk's comments that received far less attention. He said Tesla would continue doing engineering and tooling work on products it had already launched, including Optimus. And then came the statement that really changed the conversation. Musk described Optimus as the most important product development Tesla was working on that year. That is a huge statement, because Tesla was already one of the world's most valuable automotive companies. So why would a robot suddenly become more important than another vehicle? Musk's answer was simple: labor. He argued that the foundation of the economy is human labor. Factories need workers. Construction needs workers. Warehouses need workers. Logistics needs workers. Restaurants need workers. Healthcare needs workers. Almost every physical part of the economy depends on people performing tasks. And Musk's vision was essentially this: what happens when machines become capable of performing a significant portion of that physical labor? That is where Optimus enters the picture. To understand why this idea is so important, we first need to understand what makes a humanoid robot different from a traditional industrial robot. If you walk into a modern factory, you'll see plenty of robots already. They can weld, they can paint, they can move parts, they can perform repetitive assembly operations thousands of times. But there's a major limitation. Most industrial robots are designed for specific environments and specific jobs. Imagine a robotic arm designed to install the same component onto a car. It can be incredibly fast and precise. But take that robot out of its workstation and ask it to pick up a box, walk across a warehouse, open a door, and place the box on a shelf. And suddenly the problem becomes much harder. A humanoid robot takes a different approach. Instead of designing the environment around the robot, you design the robot to operate in an environment built for humans. That means 2 arms, 2 hands, legs, a human-like body, and potentially the ability to use tools and interact with equipment that already exists. Think about a factory designed for human workers. The shelves are at human height. The doors are human-sized. Tools are designed for human hands. Buttons and switches are positioned for people. If you can build a machine that can navigate that environment, you don't necessarily need to rebuild the entire factory. That could be one of the biggest advantages of humanoid robots. But building one is extremely difficult. A robot has to maintain balance while walking. It needs motors and actuators strong enough to move its body. It needs sensors to understand its surroundings. Its hands need enough dexterity to manipulate objects. And then comes perhaps the hardest part: intelligence. A human doesn't need detailed programming for every object they touch. If you see a box on the floor, your brain instantly understands what it probably is. You can walk toward it, bend down, grab it, adjust your grip, and carry it somewhere else. For a robot, every one of those steps requires perception, planning, control, and physical coordination. That is where Tesla's experience with artificial intelligence, computer vision, neural networks, batteries, electric motors, and large-scale manufacturing becomes particularly interesting. Tesla wasn't starting from zero. The company had already spent years developing systems that allow machines to understand the physical world. And Musk's long-term idea was to combine those capabilities with a physical humanoid body. At the time, Tesla said Optimus would initially focus on relatively simple, repetitive tasks. And Musk suggested that its first jobs would most likely be inside Tesla factories. That actually makes a lot of sense. Instead of immediately asking the robot to work inside millions of homes, Tesla could test it in an environment the company already controls. A factory, a controlled environment, known tools, known workflows, and engineers nearby who can monitor performance and improve the system. This creates something very important, a feedback loop. The robot performs a task. Engineers see where it struggles. The software is improved. The hardware is improved. The robot tries again, and over thousands or millions of repetitions, the system becomes better. That could be far more powerful than simply building one impressive prototype. Now let's imagine Optimus actually becomes capable of performing a large number of useful physical tasks reliably. The impact could go far beyond Tesla factories. Think about warehouses. A humanoid robot could potentially move packages, organize inventory, load materials, or perform repetitive picking tasks. Then think about manufacturing. A robot could potentially transport components, inspect products, perform repetitive assembly, or move tools between workstations. And then there are environments that are dangerous for humans. High temperatures, toxic environments, heavy lifting, repetitive movements, areas where exposure to hazardous conditions creates long-term risks. Robots don't need the same physical protections that humans do. But the biggest potential change could be economic. If humanoid robots eventually become affordable enough and capable enough, companies could deploy them at enormous scale. Imagine a factory that operates around the clock. Instead of relying entirely on human workers for repetitive physical tasks, robots could perform some of those jobs continuously. That doesn't necessarily mean humans disappear from the workplace. In fact, the transition could create entirely new categories of jobs. People would still need to design, maintain, supervise, repair, train, and manage robotic systems. But the nature of work could change. And that is exactly why Musk connected Optimus to something much larger than Tesla. He talked about labor shortages and declining birth rates as major long-term challenges. His argument was that if the number of working-age people declines while demand for goods and services continues to increase, automation could become increasingly important. In that scenario, humanoid robots wouldn't just be convenient machines. They could become a form of artificial labor. And if that sounds extreme, remember that machines have already transformed human labor many times before. The tractor changed agriculture. Industrial machinery changed manufacturing. Computers transformed office work. Robotics transformed factories. Humanoid robots could potentially become another step in that progression. But here's where we need to be realistic. There is a huge difference between building a humanoid robot and building a humanoid robot that can reliably perform thousands of useful tasks. Companies around the world have been working on humanoid robotics for years. Boston Dynamics has demonstrated incredibly advanced robotic movement. Other companies have focused heavily on warehouse automation and industrial robotics. And Tesla entered the competition with a very different advantage. Tesla's biggest potential strength isn't simply the robot itself. It is the combination of robotics, artificial intelligence, batteries, electric motors, computer vision, manufacturing, and massive scale production. Tesla's vehicle business also gives it something robotics companies don't necessarily have: a massive manufacturing ecosystem. Tesla knows how to design electric motors. It knows how to build battery systems. It has experience producing complex machines at scale. And through its autonomous driving work, it has invested heavily in neural network-based computer vision. If Tesla could successfully transfer some of those capabilities into Optimus, the company could potentially approach humanoid robots differently from traditional robotics companies. But there is still a massive challenge: cost. A robot that costs hundreds of thousands of dollars doesn't make sense for many businesses. For humanoid robots to become truly transformative, they need to become reliable, scalable, and relatively affordable. And that is where Tesla's manufacturing philosophy becomes important. Tesla has repeatedly tried to reduce costs through vertical integration, automation, manufacturing optimization, and economies of scale. If that philosophy could be applied to humanoid robots, the economics could change dramatically. But there's another comparison that matters. Cars are complicated. Humanoid robots may be even more complicated. A car mostly stays on 4 wheels. A humanoid robot has to balance on 2 legs. A car doesn't need fingers. A humanoid robot does. A car can follow roads. A humanoid robot may need to understand almost any environment it enters. So Optimus could ultimately become one of Tesla's most ambitious engineering challenges. And here's the really fascinating part. If Tesla succeeds, the robot itself might not be the most important thing. The real breakthrough could be the software and intelligence controlling it. Imagine teaching a robot a new task without physically rebuilding it. You don't replace the robot. You improve the AI. The robot learns how to recognize new objects, understand new instructions, and perform new movements. That would make the machine increasingly general purpose. It's similar to the difference between buying a calculator and owning a computer. A calculator performs specific calculations. A computer can be taught to perform countless different tasks, A truly capable humanoid robot could eventually follow a similar philosophy in the physical world. And if thousands of robots are connected to a common learning system, every improvement could potentially benefit the entire fleet. One robot discovers a better way to perform a task. That behavior can be analyzed. The software gets updated. Other robots can potentially benefit. Now imagine that happening across thousands or eventually millions of machines. That is where the scale becomes difficult to comprehend. Of course, this is still a vision, not a guarantee. Humanoid robotics faces enormous technical challenges. Walking reliably is difficult. Manipulating delicate objects is difficult. Operating safely around humans is difficult. And performing tasks for hours without failures is a completely different challenge from demonstrating something for a few minutes. So the real test isn't whether Optimus can walk. We already know humanoid robots can walk. The real question is, can Optimus become economically useful at scale? That is the question that could determine whether Musk's enormous prediction becomes reality. When Elon Musk called Optimus potentially more significant than Tesla's vehicle business, he wasn't simply talking about another Tesla product. He was talking about the possibility of turning machines into a new form of physical labor. And that's what makes this story so fascinating. Tesla became famous by changing the way people think about cars. But if Optimus eventually works the way Musk envisions, Tesla could be trying to change something much bigger, the way the world thinks about work itself. The idea is still ambitious, the technology is still evolving, and there are plenty of unanswered questions about cost, safety, reliability, jobs, and how quickly humanoid robots can actually scale. But one thing is clear. Tesla isn't treating Optimus like a simple side project. The company sees humanoid robotics as a potentially enormous opportunity. And if the technology eventually reaches the point where a robot can walk into an ordinary workplace, understand what needs to be done, and perform useful physical tasks without constant human supervision, we could be looking at one of the biggest technological shifts of the next few decades. So what do you think? Could humanoid robots like Optimus actually become more important than electric cars? Or is Elon Musk's vision still far too ambitious? Let me know your thoughts in the comments. And if you enjoyed this breakdown, hit like, share this video with someone interested in Tesla and robotics, and subscribe to the channel for more technology stories explained in a simple and interesting way. Because the future of robotics may be closer than we think.